All right, now let's look at a couple examples using the intermediate value theorem. So remember, intermediate value theorem tells us that provided the function is continuous on the interval given and the f of the endpoints of that closed interval are different, then f is going to take on all of those values in between those endpoints values. So in this case, we want to verify the intermediate value theorem applies to our indicated interval and then find the value of c guaranteed by the theorem if f of x is equal to x squared minus 4x on the closed interval -2 to 3 where f of c is equal to 5. So first thing we need to do is we need to verify this meets the criteria for the intermediate value theorem. So first piece, is the function f of x equals x squared minus 4x continuous on the closed interval -2 to 3? Well, we know the answer to that is yes, so f is continuous on this closed interval -2 to 3. Why? Because it's a polynomial. So because it's a polynomial, polynomials are continuous everywhere, right? So continuous on -infinity to infinity. And -2 to 3 is certainly in that interval -infinity to infinity. So it meets that piece. And yes, you got to show all of this. Next thing we need to make sure is that f of -2 and f of 3 are different. So f of -2, substituting in -2 into our function, is -2 quantity squared minus 4 times -2. So that's 4 plus 8, which then gives us 12. And f of 3 then, so that's 3 squared minus 4 times 3. So 9 plus 12, 9 minus 12, then gives us -3. So since these are different, so -12 does not, positive 12 does not equal -3, then intermediate value theorem applies. And because of this, we know f is going to take on all of the values between these two y values, so between -3 and 12 on the interval -2 to 3. So there is, because of the intermediate value theorem, so 5 is between -3 and 12, so there's going to be some c value in there where f of c is equal to 5. Therefore, we got to find that value now. So if f of c equals to 5, then, well, that means what's f of c? F of c is just c squared minus 4c equals 5, right? And we've got to solve this now. So easiest way to solve it, get everything on one side, set it equal to 0. So c squared minus 4c minus 5 equals 0. And in this case, this factor is fairly easy. So this becomes c minus 5, c plus 1 equals 0. So c minus 5 equals 0, c plus 1 equals 0. Remember, we're using the zero factor property from Math 171 here. And then that means that, in this case, c equals 5, c equals -1. So we have two different c values here where f of c would equal 5. But remember, it has to be on the interval -2 to 3. And in this case, the only one on the interval for x equaling -2 to 3 is c equaling -1. C equaling 5 is not in the interval. So in this case, the value of c we care about, the one guaranteed by our intermediate value theorem, is c equaling -1. Alright, so now let's look at the next one, which is kind of a twist on the, well, in a way, a twist on the intermediate value theorem. It's not quite the exact same as what we just did. So we want to explain why f of x equals x cubed plus 3x minus 2 has a 0 on the closed interval 0 to 1. If you look at the graph of this cubic function, you'll find it does indeed have a 0 there. Now, we can't find it by hand very easily because we can't factor this. But we know there is a 0 there. So why does it have a 0? So the intermediate value theorem helps us explain that. So let's look at the criteria for the intermediate value theorem. So in this case, f we know is continuous on the closed interval 0 to 1. Again, since f is a polynomial, right? It's continuous everywhere. So first piece is done. Second piece, we got to make sure f of 0 doesn't equal f of 1. So f of 0 is 0 cubed plus 3 times 0 minus 2. So that's just negative 2. F of 1, 1 cubed plus 3 times 1 minus 2. So that's 1 plus 3 minus 2, which is 2. So negative 2, 2 are not equal. So f of 0 is not equal to f of 1. So because it meets these two criteria, so the intermediate value theorem applies. And so because the intermediate value theorem applies, f takes on all values between negative 2 and 2 on the closed interval that we were looking at, 0 to 1. And so guess what? Since 0 is between negative 2 and 2, we know there's going to be, by the intermediate value theorem, there's going to be a c on 0 to 1 such that f of c equals 0. Or in other words, we have a 0, f has a 0 on 0 to 1. So by the intermediate value theorem, f of x equaling x cubed plus 3x minus 2 has a 0 on 0 to 1.